One last thing about sectors before we move on to segments is that remember the area is going to be the central angle over 360 pi times the radius squared. Well, what if they're asking for the area of a semicircle? Well, what would the central angle be for a semicircle? That's 180. It's a straight line. Pi times the radius squared. So for that reason, if you're asked to find the area of a semicircle, you can go right to the equation. Area is 1/2 of the whole circle. Just kind of saving you some calculations, saving you some steps. Now, for another term, and that is segment. So we've had sector. Sector looks like a piece of pizza. A segment is the region bounded by an arc and a chord. Bounded by an arc and a chord. And we may find the perimeter of the sector. The perimeter of the segment. That would be the length of the chord plus the length of the intercepted arc. That would be the distance around. And if we want to find the area, these are the steps we're going through. The area of a segment is going to be the area of the sector, as if it was all filled in, minus the area of the triangle. So we're going to, if we wanted to find the area of this segment, we would find the area of this whole sector, and then we would back out the triangle, and we would be left with just the area of the segment. So just be careful on what question they ask, if they're asking for perimeter, if they're asking for area, and if they're asking about the segment, which looks like a slice of pizza, the segment, which is separated by a chord and an arc, or if they're ask for the sector, which looks like a slice of pizza. All right, so let's look at this example. They want us to find the exact area of this segment. It's bounded by this chord, AB, and it intercepts the arc, AB. And we are told the arc measures 90 degrees, which means our central angle also measures 90 degrees. All right, so these are multi-step problems. How are we going to find the area of this segment? The area of the segment is going to equal the area of the sector, that's the part that looks like a slice of pizza, minus the area of that triangle. It's like an air triangle. So we want the area of the segment here. So the area of our segment is going to equal, all right, what's the area of the sector? The area of this sector is going to be central angle over 360 pi times the radius squared. And then what is the area of a triangle? The area of a triangle is 1/2 the base times the height. So we're going to have to fill in for some of these unknown pieces of information, but the good news is we have all the data that we need. So the area of our segment is going to equal 90 over 360 pi, and my radius is 12 inches, so 12 squared, minus 1/2. This is a right triangle, so my base is 12 and my height is 12. So the area of this segment is going to equal 1/4 pi times 144, because 12 squared is 144, minus 144 minus 1/2 times 144. All right, so our area is going to equal 1/4 of 144 is 36. So we have 36 pi minus 72. That's our answer, and of course, since we're talking about area, the units are going to be inches squared. This is the area of the sector, and this is the area of the triangle subtracted out. Now, what if we were asked to find the perimeter? What if we were asked to find the perimeter? We're not going to go through this problem right now, but if I wanted to find the perimeter of a sector, let's go ahead and draw one here. So let's say that here is sector endpoints AB on the arc. And we want the perimeter of this segment. The perimeter of the segment is going to equal the length of AB, that's the length of the chord, plus the arc length of AB, that's the arc. The chord and the arc, and that's how you would find perimeter. And one last relationship we want to cover here is where P represents the perimeter of a triangle and R represents the length of a radius that's inscribed in the triangle. Okay, so here we are. We would have the perimeter of this triangle, and we would know the radius of this triangle. The area of the triangle will equal 1/2 the radius times the perimeter. 1/2 the radius times the perimeter. Now we already know how to find the area of a triangle if we were to use Heron's theorem, but this is just another way if you're told there's an inscribed triangle. So here we know that the area is 1/2 the radius times the perimeter. So this way we don't have to find semi-perimeter and take square root, the things that you have to do to go through Heron's law. Our area is going to equal 1/2. We're told the radius is 2 centimeters. And what is our perimeter? 5 plus 12 plus 13. 1/2 times 2 is just going to be 1. And 5 plus 12 plus 13 is 30. And area is always units squared. So what we just saw was a right triangle. The area of the triangle could have been determined using Heron's formula.